Hello guys, welcome to Ramta Solutions. Today we are looking at an example that says 1.5 moles of aluminium reacts with 3.00 moles of chlorine. The reaction is 2 aluminiums plus 3 chlorine gas gives us 2 aluminum chloride molecules. Okay, now the first question says which reactant is limiting? So this question, because it's asking us which reactant is limiting, it means that these two substances are not fed in stoichiometric proportion. Okay? They are not fed in stoichiometric proportion. Now let's look at the available ratio. So we will say, what is our available ratio? Now, available ratio is basically the ratio of the substances that we are reacting, actual number of moles. So let's say I will take aluminum. I will take number of moles of aluminum over number of moles of chlorine. Okay, so what are they? Number of moles of aluminum is 1.5 moles, while number of moles of chlorine is 3.00. Even if I had written 3, it's okay. So this looks to me like it's 0.5. So the available ratio is 0.5. Now we are going to look at the required ratio, which is the ratio according to stoichiometry or according to the chemical equation. Okay, and let's look at it. Now the required ratio will be, we had said it's aluminum, so it'll be, how many moles of aluminum do we need in this reaction? We need 2 moles of aluminum. And how many moles are we looking at for chlorine? The coefficient is 3, so it'll be 3 moles of chlorine. What is this? 2 over 3. So we are getting 2 over 3. Right? We are getting 2 over 3. Now what is 2 over 3? 2 over 3 is 0.67. Okay? This ratio is 0.67. The required ratio is 0.67, and then the available ratio is 0.5. Now, remember the mnemonic that I told you about in the first video. We said our mnemonic, to help us remember this, we will say a green robe David loves. Right? A green robe David loves. So if available is greater than required, denominator is limiting. Alright? If available is greater than required, alright? If available is greater than required, denominator is limiting. Okay, denominator is limiting. Denominator is limiting. Now, what did we get here? Available is less than, right? For our answer, going back, available, all right? Available is less than required, all right? Is less than required. Therefore, what does it mean? Numerator, what is numerator? Our numerator is aluminum. Therefore, aluminum is limiting. Our aluminum is a limiting reactant. Okay, aluminum is a limiting reactant. Okay, so that's number A for us. Okay, all right, perfect. Remember, I'm saying aluminum because aluminum is our numerator, right? Our mnemonic was saying a green robe David loves, meaning if available is greater than required, denominator is limiting. However, in this case, available is less than required. Therefore, this means numerator is limiting. Okay, perfect. Now, question B, how many moles of aluminum chloride can be produced? These will be according to the number of moles of, the limiting reactant. So what is the coefficient of aluminum trichloride? It's 2. So it will be number of moles of aluminum trichloride over 2 is equal to, what is our limiting reactant? It is aluminum. And what is the coefficient of aluminum? It's 2, right? It's 2. Therefore, this means number of moles of aluminum chloride is equal to number of moles of aluminum over 2 multiplied by 2. As you can see, 2 divided by 2 is 1. So this is number of moles of aluminum, right? What does it mean? It means number of moles of aluminum trichloride is equal to number of moles of aluminum. How many moles of aluminum did we feed? 1.5. So since we fed 1.5, this means we can also form 1.5 moles of aluminum trichloride, isn't it? We can also form 1.5 moles of aluminum trichloride. Okay? Perfect. Now, let's then proceed to question C. Question C was saying to us, how many moles of the excess reactant remains after the completion of the reaction? Remember, when you have a limiting reactant, the other substance which is not used up completely is in excess. So, again, we need to know how much of chlorine do we need to react with the 1.5 mole of aluminum. Okay? We need to know that. Okay, guys? We need to know that, so let's get into it. So, number C, number of moles of chlorine over, what is the coefficient? I think it was 3, is equal to number of moles of aluminum over the coefficient was 2. Let me confirm. Yes, 3 and 2. Perfect. So, what is this? This will be number of moles of chlorine is equal to number of moles of aluminum over 2 and then multiplied by 3. What are the number of moles of aluminum that we need? I think we said we have 1.5 over 2 multiplied by 3, right? It was 1.5. Now let's see. 1.5 over 2 multiplied by 3. What do we get? We get 2.25 moles. So these are the number of moles of chlorine that are required to react completely with aluminum. Okay? Therefore, our excess is, remember, chlorine, we fed 3, and then what do we need? We only need 2.25. So what is our excess? It is 0.75 mole. Let's see. Yes, the question was saying how many moles of the excess reactant remains after the completion of the reaction. Therefore, 0.75 mole of chlorine gas remains. Okay? So this is how you go about your calculation of limiting reactants. Remember, guys, the thing that's important is to know this. If you can know this mnemonic, a green rope David Labs is basically saying if available is greater than required, denominator is limiting. Okay? I like using this. So with that being said, it's a wrap, and I hope you guys will master this concept of limiting reactant. So bye bye.